Hello and welcome. We are starting now. Anyone who has already joined? This is Sudhanshu Tripathi. I was teaching chemistry in University, Ravenshaw University, now University. At that time when I was working, it was Ravenshaw College. I was teaching chemistry in both undergraduate and postgraduate level. And as you guys know that I have been passionate about, high school level teaching chemistry, particularly giving them the real concepts leading to not only to their class 11, 12 board, but also making them fit for NEET and as well as JEE main and advanced. So how many of you have already joined? And I'm not able to see the messages. Messages should come. It's not coming. Viewer message is on. Yes. So viewer message should come. Yes. Now I can see the messages. Rituparna is there. Just write down once again that you are there. Good morning. Yes, for me it is good morning. Good evening to all of you. Yes. Now the live is going on. And comment is coming. So we'll be starting. Let me show you the screen where I would like to show you the PowerPoint. Now tell me if you remember what is the meaning of enthalpy change. Yes, you can write down what is the meaning of enthalpy change. I will not ask you what is internal energy change. Internal energy, of course, then I will ask you what is internal energy change. But now I'm asking what is enthalpy change in a broad-based manner. What is enthalpy change in a process that we discussed yesterday? Yes, it is the heat absorbed or evolved now it is coming. My video is coming. Oh, yes. Yes. Thank you. Yes, now my video will come. Is coming? My video coming? Video must, it will come. Just wait a sec. You will tell me that a video is coming. It's coming? It will take some time. There is a lag. Now, enthalpy change is actually the heat absorbed or evolved during a process at constant pressure. That was the starting point of enthalpy. This change, enthalpy change, del H, is the heat absorbed or evolved at constant pressure. And what is internal energy change in that way to express? That is the heat absorbed or evolved. Heat, that means energy mode of transfer is heat at constant volume. And we knew which cases the volume change does not occur. We have discussed. So that del H is equal to del U. And del H is equal to QP, which is equal to, in our chemistry convention, it is del U plus P del V, because our work is minus P external into del V. Therefore, when it goes to the other side, it becomes del H is equal to del U plus P del V. And for chemical reactions, it is del nRT. Del nRT. Now, I am showing you the heat capacity graphs. Actually, the enthalpy versus temperature graph, that the slope of that graph is nothing but dH by dt. dH by dt. Differentiation, not integration. That will give you the slope of the graph. It is a linear graph almost. And the internal energy versus temperature graph is lying below it. This is Cp, and at a particular temperature. But for over a broad range of temperature, the Cp, Cv remains constant. Particularly for gas, they remain constant. But they remain constant. But for liquids and solids, there are no two specific heat capacity or heat capacity. It is only one heat capacity. We can call it at constant pressure, no constant volume, there is nothing. So that undergoes changes during phase transition. So this is du by dt, that gives you Cv. This is for gases, say usually they don't change. Now look to how solid, in the solid state it remains constant, the heat capacity. But the moment there is a melting transition, then there is an inflection point, changes to a higher value and then remains constant. Again, when there is a vaporization, boiling, then it again goes to an inflection point and then carry on. So we have discussed all this. And also, we have seen that del U is equal to N Cv delta T. We have started, because Cv prime, this is the molar heat capacity. It's not the molar heat capacity. It's only the heat capacity. It is the only heat capacity of the entire amount. is del U, del T. These Cv prime, del U, they are extensive property. But Cv is an intensive property, is molar heat capacity. So multiplied by N number of moles, that gives you Cv prime and del T. Similarly, del H is equal to N Cp del T, that we have studied. And Cp minus Cv is equal to R. This is called the Mayer's equation. And for monoatomic gas, I have already told you 3 by 2R, Cv, Cp 5 by 2R, diatomic 5 by 2R, 7 by 2R Cp, polyatomic 3R, 4R. And the ratio is called the Poisson's ratio, which is maximum for monoatomic, minimum for polyatomic. And Cp minus Cv is equal to R. The derivations I have already given. Sieve is yet to join. Sieve. Okay, he will join soon. Now this is the main source where this 3 by 2, 5 by 2 have come. Actually, the internal energy I have given you in my notes, that internal energy, absolute internal energy, is given by the expression F into half nRT. F is the total degrees of freedom that a system has. I'll tell you what is that degrees of freedom. Half nRT is for each degree of freedom. That is the law of equipartition theorem. So as many number of, a monoatomic gas, a single atom, can have only translation. It cannot have any rotation. A single atom has no rotation. That is not considered as a rotation. They say the same spherical atom rotates. That is not considered. Bond, if there is a bond, then it rotates across the bond. So for a monoatomic gas, there is the atoms have only 3 translational degree of freedom: x-axis, y-axis, z-axis. So you can define the position of a monoatomic particle by the 3 dimension using 3 coordinates x, y, z. So that x coordinate, it will store energy, y coordinate, so there are 3 components, so there are 3 energy storage processes or ways. So therefore F is 3 by 2 for monoatomic, therefore 3 by 2, and since Cp is more than Cv by R, so it will be 5 by 2. Similarly, diatomic, the degrees of freedom becomes 5, 3 translational and 2 rotational. When there is a bond, AB bond, the rotation about the bond axis is not taken as the real rotation, but the other axis, xz, supposing this is xy, that rotation is not considered. But xz and yz rotations, they are 2 degrees of freedom which will store energy. So 3 plus 2, 5. So 5 by 2R. And therefore Cp 7 by 2R. Polyatomic gas, there are ozone considered to be linear, but you have 3 degrees of freedom. 6 total, 3 translational and 3 vibrational, particularly non-linear molecules. They also xy plane also, if linear, 2. But non-linear, I'm not talking of ozone or ozone, yes, ozone. But not talking of N2O, ozone. So it will have 3 rotational degrees of freedom, 3 plus 3, 6. So F के जगह पर हम 6 by 2, so it is 3 RT. So this is the normal way, but vibrational, the bond vibrates in different ways. 3n minus 6 possible ways for non-linear molecule, and for linear 3n minus 5. And each vibration has its kinetic and potential counterparts. So 2 into 3n minus 6. So all these vibrations we don't consider, because that vibrational degrees of freedom comes in when the temperature is high, more than 100 degrees Celsius or more. So we don't take vibrational degrees of freedom, and we have already done that. Now we will go into a problem. I will show you. Where is Cp prime? Cp prime is the heat capacity at constant pressure. That is an extensive property. Prime means dash. This dash I say prime, not prime minister. Cp prime. Cp prime means dash. So Cp dash, Cp dash, they are actually the entire bulk. That is the heat capacity of the entire 5 kg, 10 kg, whatever you take. And but if the number of moles is n and Cp and Cv are the molar heat capacity at constant pressure is Cp and constant volume is Cv, then n into Cv will give you Cv dash. I'm saying prime to dash, and n into Cp will be Cp dash. So in place of Cp dash, I write NCp. In place of Cv dash, I write n into Cv. You understood? You understood? Hello. Ritu, you understood what is prime? Prime is not prime minister, it is just dash. Are you there? Your message is not coming. Ritu, if you are, okay. Now, look to this problem we left. See, look to this problem. Calculate the work done in respect of 1 mole of an ideal gas in a piston fitted cylinder at 24.83 atmosphere. I used to say 20 kg sand or 20 kg weight. It's actually 24.83 atmosphere pressure it was there, and 300 K to expand to 10 liter. 1 liter. It was 1 liter. 1 mole, and also, we don't know, but we can find out. PV is equal to nRT is given, everything is given. So we find out the volume will be coming 1 liter. It was 1 liter to expand it to 10 liter. In one stroke, number 1, if the pressure is reduced to 1 atm in a single stroke, single step, that is irreversible. This becomes irreversible, number 1. It was 24.83 atmosphere. That weight will be taken out. Weight means pressure will be taken out, and 1 atmosphere weight will be kept. So it will be suddenly expanding. It's an irreversible process. So find out the work done. Then if external pressure is reduced first to 5 atmosphere, so it will be doing work under 5 atmosphere. Again, irreversible. And then remove the 5 atmosphere weight and put 1 atmosphere. It will again expand under 1 atmosphere. What is the total work done? And compare it with if it is done from the beginning, ideally, reversibly, and at constant temperature. That is the graph. That is a curve. So what would be? That is, you remember the formula for finding the isothermal, reversible expansion work or compression work, which is same. That is minus 2.303 nRT log V2 by V1 or P1 by P2. So, and I will show you the calculation to save time. Now see, this is this one. First we will be finding this one, the small rectangle, minus P into del V. Final volume 10 and initial volume 1. PV is equal to nRT we have used to find the initial volume 1. So it is 9 liter atmosphere, 1 liter atmosphere is 101.3. So we found that the work done by the gas is, expansion work is 912 joules. Then the first from 20.83 atmosphere to 5 atmosphere. That means it will work under 5 atmosphere. So minus P, the constant pressure is 5 atmosphere. And again PB is equal to nRT gave us the volume at 4.92 at 5 atmosphere. So from this was the final volume, and it started from initial volume 1 liter. So 4.9 minus 1, B2 minus B1, and then minus P del B. Then under 1 atmosphere to 10 liter, final volume 10, it went from 4.9. So if you add these two rectangles, this is a relatively bigger rectangle ending at 5 atmosphere, ending at volume 4.9 liter. So this, and again from 4.9 going to 10 liter at constant 1 atmosphere. So this, so the sum of these two rectangles will be definitely greater than the small rectangle, but definitely smaller than the curve, the area bound by the curve. It was 2492. But look to the case of minus 2.303 nRT log V2 by V1, we find it is incredibly large, 5738.6. So our interest is to see our process is how much close to this ideal value. This we cannot reach. This is studied by everybody. All the technologists and others who are handling heat work, they study, they set their target. Our target is this. So more the number of steps, more is the work done. If supposing 24.83 atmosphere to first 20 atmosphere, then 20 to 15, 15 to 10, 10 to 5, 5 to 1. So the rectangles would have been more. Bigger, smaller. So if you add, this addition will be very close to, not equal to, the area bound by the graph, by the curve. So this numerical, we have to do it. Now, in this case, if the heat evolved for the following reaction at constant pressure, that is del H. Constant pressure means del H. Q is equal to del H. QP is equal to del H. Is this much. Then find the heat evolved at constant volume, del U. We know the relationship del H is equal to del U. This would be U. Earlier I used to write E. Del H is equal to del U plus P del V. In place of P del V for chemical reactions, we write del nRT. So in this reaction, when benzoic acid solid is combusted in air or oxygen, it gives carbon dioxide gas and water liquid. So ignoring the solid and liquid, del N becomes 7 minus 15 by 2 is minus half. So del H, which is given minus 20, is equal to del U, which we have to find out, plus del N. Del N is minus half into, since we will be expressing our answer in kilojoule, so 8.3 I made it 0.0083 kilojoule, or T is 298. 25 degrees Celsius means 298. So that del U E comes to be minus 318. So there is a decrease of thermal energy or internal energy by this amount. Although it has gained, it has lost 320 kilojoules. It is an exothermic process, but the actual decrease in thermal energy has happened by an amount 318. The remaining has disappeared as work, return gift. So now I shall be using welcome. Let us, yes, look to, oh sorry, different processes. Oh, we shall be applying First law to different processes. First, let us take up isothermal. Usually, isothermal is reversible. Has to be done in a slow process. Reversible means slow. We'll be talking about reversibility, irreversibility in chemical change, chemical reactions after some time. Usually, but there can be also irreversible isothermal. So these processes are done inside a thermostatic bath that is called thermostat. So those processes which are done under constant pressure, they are put in a large reservoir with an electronic arrangement. Any micro change in temperature will be adjusted by give and take of heat. So the temperature is always maintained at a fixed value. So any process which is carried out isothermally, temperature constant, usually is slow, but it can be also fast. You put inside a thermostat, but do rapid compression there inside. You also be inside there, do rapid. So it will be same thing as irreversible process, but under constant temperature. So usually we study isothermal reversible process, which goes very slow, and the graph we already have studied. Now here, since temperature is constant, U is constant. Temperature is directly a constant mass. I have already told you. U is measured by thermometer. I have told you del U, the change. Of course, only H cannot be measured by any way, but del U, the difference can be measured. NCV delta T is del U, NCP delta T is del H. So, therefore, del U is equal to 0. So our first law, the bank balance is equal to the dollar plus Indian rupee, that becomes 0 is equal to Q plus W. So here Q is equal to minus W, or W is equal to minus Q. So this is the relationship. Whatever heat will be absorbed will be turned into work. Whatever work will be done will be thrown out as heat. Whatever work will be done on the gas will be thrown out immediately as heat to the surrounding. Surrounding is a thermostat, it will absorb. It is a large reservoir, it can absorb, it can give, it can take and maintain the temperature because it has got a electronic arrangement. So this is, we already know the graph for that, and we know how to find the work done, minus 2.303 nRT log V2 by V1. And in this case, del H is equal to del U plus, because everything is changing, pressure, volume, both the things are changing, and PV is equal to constant. So the differential of a constant is 0. Therefore, remember that in isothermal process, not only del U 0, but also del H, del U both are 0. It will be required for your NEET examination or JEE examination. And Q is equal to minus W. Temperature remains constant. Whatever heat comes is used for work. It comes, expansion work. Goes, compression work. Then coming to immediately we shall take adiabatic. Done under insulation. That is called an isolated system. Adiabatic process. And there Q is equal to 0. There is no heat transfer. It is sealed, insulated. So no heat transfer can occur. But there will be definitely, if you take up the first law, dollar plus, let me write Q, capital Q, because I have been writing capital Q, plus W. So if this becomes 0, then del U will be equal to W. Temperature will rise if you work done. Supposing you have a thermal flask type of cylinder, movable cylinder, all insulated, even the piston, everything, and you compress. That doesn't mean that temperature will not increase. Temperature will increase, but not due to heat transfer, but due to work transfer. Remember this, temperature increase or decrease is not merely due to heat transfer. It may also be due to work transfer. Remember this, work and heat, they are the two modes of energy transfer. Which energy? Thermal energy. What is we call internal energy. So, in this case particularly, work done is a state function. Adiabatic work done is now become a state function because it is equal to a state function. So only when you perform work, expansion work or compression work in an adiabatic way, that is in an isolated system, then that work done is path independent. Whether you go slowly or fast, it is path independent. Of course, slowly, fast, there will be difference. I'm sorry. Whether you stop here and then start, or go in one way, same. It depends on the initial state and final state. But definitely, irreversible, reversible, those processes are there also in adiabatic. We shall be studying that. And interestingly, compared to isothermal, where temperature was kept constant, P and V were varying, changing in a reciprocal manner. The pressure increases, volume decreases. But here, all the three, remember this, temperature, pressure, volume, all vary. Supposing you compress, or so you expand in an insulated system, or in an isolated system, you expand. So, the work done will be due to the loss of its own internal energy. So internal energy घट जाएगा क्योंकि work done कहीं बाहर से heat नहीं आएगा और जाएगा. So the work done has been done entirely by its own INR रूपी, इसको उन्होंने खर्चा किया है. तो इसीलिए इंटरनल एनर्जी घटेगा, घटने से टेम्परेचर ड्रॉप होगा, सो कूलिंग होगा. And since expansion, volume be increased. Since volume is increased, pressure is decreased because the gas which was there, mass of the gas was fixed. It is now spread into a larger volume, so pressure will drop. So pressure decreases, volume increases, temperature also decreases. All will vary. And here also there are two processes. Just like in isothermal, there are two processes. Reversible, which I have written. The work done, the NRT wala jo work done, that is for reversible. but that can be irreversible. That minus P external into delta V, done under constant temperature. इसमें भी irreversible and reversible दोनों है adiabatic change में भी. Okay. So yesterday I found that streaming, I will take your feedback, Ritu, later. How is the streaming efficiency of Facebook? I'm not able to feel anything because I am delivering. I'm just looking at my video, which was stopped. I didn't see. Ritu, you have rightly reminded me, and I changed. But Facebook might be good in streaming, but it's extremely, maybe it is not interested to retain the video. Big video it doesn't retain. Yesterday I was wanting to edit, to put the PDF links in Facebook. So what happened, it took the PDF links and the original video file completely vanished. I tried my level best, I could not resurrect. It is already deeply buried inside some grave, which I could not resurrect. So thank God that I am recording this class or this lecture in my own system. Now after the class I am uploading in YouTube. I did that yesterday and immediately gave the link in Facebook, so that was displayed. The thumbnail was displayed. So we'll see what will be better next time after this 5-day course, when I will go for other series for other topics, important topics. Then whether I will choose same Facebook for live streaming or not. Only for study purpose, I will be using Facebook for my promotion. I mean, I'm not money promotion. To inform the parents and other persons who are my friends that this has been already done. You ask your, wards or students to take the benefit. We'll decide that later. Now, we'll be coming back to this after a while. But before that, let me tell the P versus V graph. Starting point is say 20, always 20 atmosphere. So if this is 1 atmosphere, if this is isothermal, this is called isotherm. The graph is called isotherm, the PV graph. Therm is here. The adiabatic graph will run below it. The adiabat, it is called adiabat. It will run below during expansion. Why? Why? Because it is a smooth graph. Smooth graph. Why? Because at any constant pressure, if you compare the volume of adiabatic will be less. Why? Or conversely, if you look to any volume, the corresponding pressure will be less because the temperature is less. Expansion में टेम्परेचर धीरे धीरे जितना आप एक्सपैंड करोगे उतना ही इंडियन रुपी आप खर्चा करोगे और आपको टेम्परेचर घटता हुआ नजर आएगा. तो सिंस प्रेशर डिक्रीजेस since temperature decreases, pressure also decreases at constant volume. That is Amundsen's law. Or at a fixed pressure, the volume is less in adiabatic, because according to Charles' law, less the temperature, less the volume. So adiabat will have less volume at every point at constant pressure. Pressure constant, if you compare between volumes, the adiabat will have a lower volume during expansion. And if you keep volume constant, then the pressure will be less in the adiabat, because Hamilton's law, less the temperature, less the pressure, there is a cooling. So remember, this is the adiabat, which will be running below but same. And this area bound by each curve, that will give the reversible work done. The red one below that is the reversible isothermal work done, and green one below that will give you the adiabatic but reversible. Both are reversible. Slow. But if you look to irreversible process, this one, adia ir, and this one, if you look to isothermal, reversible. So with this much of, similarly, if you look to compression, people commit a mistake here. Start from a higher value, go to a higher volume, and go to a lower volume. That is compression. Or start from a low pressure, go to a high pressure. So if this is the graph for isotherm at constant temperature, this is the graph for constant temperature. We are going from here to here. This is isothermal, the same. Whatever, supposing the V and V1, V2 are same. So this will be V initial, this will be V final. Doesn't matter in compression. This is compression, this is expansion. The adiabat will run above. That is exactly the opposite. It will run above. All are isothermal. Because at any fixed pressure, the volume of adiabat will be more. Because temperature will be more. Compression, your work, whatever means surrounding is doing work onto the system, that will be converted to its internal energy. Del U is equal to W. No heat transfer, but internal energy. Temperature can rise and fall. In that case, it was a cooling effect. This time it is a heating effect. So, more the temperature, more is the volume. Therefore, the adiabat runs above the isotherm in compression. But during expansion, it runs below. These things, there is no time for the teacher to explain the concept, the inner concept, what is really happening. Adiabatic, you apply this equation, you can get. But what is happening? No necessity. Are you going to be a doctor? Are you going to be an engineer? What is the knowledge of studying it? But no, whatever we study with all understanding, conceptual understanding, not superficially, mechanically. So, the work done in adiabat, obviously the work done in adiabatic will be more than the isothermal, but both reversible. I am not talking of, again, if it is irreversible, then under constant pressure, it will be going from here. it will be going same volume, it will go up. So the area bound under this will be even more than that. So if it is irreversible compression, both in adiabatic and isothermal, adiabatic will have greater irreversible work than isothermal. In reversible process, obviously adiabatic is more than isothermal, and also irreversible process, adiabatic is more than isothermal, which we have already discussed before and now. But for the first time, we are comparing between adiabatic and isothermal graphs in reversible and also irreversible. This all said and done, let us go for isobaric. So where P constant. So here, oh, by the way, adiabatic, I have not told you that it has got a del H value, which is equal to N Cp delta T. There is a change in temperature. So you will be asked what is the enthalpy change in this process. So you have to apply for everything. Del U is equal to N Cv delta T. For anything, del H is equal to N Cp delta T. So you find the two temperatures so that you know Cp. If Cp value or Cv value is given, it is well and good. Otherwise, we know if it is diatomic, straightway Cp is 7/2. If it is monoatomic, Cp is 5/2. If Cv is needed for del U, it is 3/2 for monoatomic, 5/2 for diatomic. So we know all this. Sometimes in the problem, you will be given Cp value. If Cp value is given, you want Cp, you add 8.3, that will be Cp. Now that is actually del U plus everything is changing. So we can call it P into del V. Now, this is for microscopic change. It will be P2 V2 minus P1 V1. But for microscopic change, dH is equal to du plus dPV. So that in place of this, in place of this, we can write du plus P dV plus V dP. So those things will be done in differential scale, in infinitesimally small scale. But in large scale, it reduced to P2 V2 minus. But we don't need this. Simply Cp delta T will give you del H. In fact, del H has a real meaning. It was not real meaning. It was originated from constant pressure, isobaric experiment. But it was applied to all, because not all adiabatic processes are done in a closed system. Suppose there is an open system, but insulation open somewhere. So in that case, del H will give you the maximum work. Of course, work done is del U, but del H will be more than del U if it is done in a different way in an open system. The total output of work will be more. So to know that, del H is also required in many processes other than a few which we have already listed. One of them is isothermal, where del H is equal to 0, del U 0, del H 0. But yes, adiabatic has a del H. Remember this. Isobaric, हमने गलती से लिखा. So it should be written here. dH is equal to du plus P dV plus V dP. So in isobaric process, constant pressure. So simply our first law will be del U is equal to Q plus W. So whatever we learned, this is del H. Constant pressure means del H, and W is minus P del V. So this is equal to del H is equal to del U plus P del V. And in place of P del V, we should write, because PV is equal to nRT. PV is equal to nRT. In chemical reactions, if number of moles changes del N, here del V, P remains constant. But when number of mole is constant, mass is constant, if something is changing here, supposing volume is changing, pressure is constant, then definitely the other variable in the right side will be, temperature. So P delta V is equal to nR delta T. In chemical reactions, temperature was constant, pressure was constant. We are writing delta nRT. But in isobaric process where mass is constant, N is constant, we are writing del V varies with del T. So in place of P del V, let us write nR delta T. So that will give you del H, or which is also equal to N Cp delta T. We'll just play. We'll be solving problem. Oh, hello, Mahesh. You missed a little portion, but anyway, you can watch out because I will be uploading in YouTube later. You will watch out. Very important, because you are not simply learning some equations from me. That people learn from anywhere. School, they learn. Our capable teachers, they will feed you all equations and you solve problems. But I am disseminating. Why? I am not keen in number of students. I am keen in those who want to understand the real concept of thermodynamics, which is very, very intriguing. And even I can dare say, without studying oneself, having a keen interest and developing the real experience, studying more, realizing it, one can disseminate to the level of conceptual clarity in thermodynamics. Therefore, it is natural for the part of a teacher not to go into the concept. What is really happening? And how the true world is different from the ideal world. Supposing I do not know something, how can I say? If you ask such a question to me, then I will say, I'm sorry, I don't know. So that, and paucity of time. Jhilu Jhilu Pranam. Tome kon student ma? If so, what is your name? Yes, you used to comment in my other videos, other reels, other posts, because Facebook is a versatile platform. It showcases your plus points in whichever manner you have. Maybe rosei, maybe cooking, or maybe decoration in house, or maybe studying, or maybe singing, maybe dancing, whatever. That great platform has made the entire population to live more happily. But sometimes we indulge in that. Just like somebody is addicted to alcohol. Similarly, some of us are getting more and more addicted to this social media platforms. And people around us might feel the difference if they are not also equally addicted. There is a famous Odia Dhaga, which I refrain myself to tell that here, which says that if तू भी जहाँ मु भी सेया ताहले आमे कहीं के ते दुख करिबा तू तो जहाँ मु तो सेया तू तो फेसबुक वाला मु तो फेसबुक वाला ताहले आमे कहीं के ते कष्ट दुख करिबा चलो हाँ Siddharth, you joined late, doesn't matter, better late than never. I have to revise. Now in isothermal process, the internal energy doesn't change. Del U is equal to 0. So from first law, Q is equal to minus W. That is, whatever heat is absorbed, it is used in expansion work. Khatam. No change in internal energy, so temperature remains same. And we have to work out that process in a huge device called thermostat, which gives and takes heat and maintains the temperature. There is an electronic arrangement which maintains the temperature at constant value. And whatever heat goes, expands. Heat comes inside the expands, goes outside, compresses. So Q is equal to minus W. And here del H has a meaning. Del H is also 0 because P and V both are changing and PV is a constant. So any differential of a constant value is 0. Therefore, if you are asked in the examination what is del H, you will say 0. Although it has got no practical meaning. But del H is 0. You have to say that. Now compared to adiabatic process. So isothermal has two possibilities. One is reversible, the curve, and the irreversible. That goes under the final external pressure. The final that you are putting 1 kg in place of 20 kg. That will work. So this is much less in expansion, but more in compression, that we know. So that is irreversible. Reversible traces the same path. Infinitesimally slowly, is an ideal process. So, but similarly, the adiabatic, which is done under insulation, complete insulation, you can have also expansion and compression. Here, Q is equal to 0. So no heat exchanges. But that doesn't mean that temperature will not change. Temperature changes both by heat exchange as well as work exchange. So if work is done, so in this case, the first law is reduced to del U is equal to W, adiabatic. So in this case, adiabatic work done is a state function. Because it is equal to a state function, a change in state function. So adiabatic work done is path independent. This is the special case. Whatever work you do, it increases the internal energy, human surrounding onto the system. And if system expands, does some work, it has to invest its own Indian rupee. So there is a decrease in temperature, there is a cooling effect. So I told you yesterday that even in a closed system having dithermic wall, if you do anything suddenly, I'm talking of irreversibly, then it is as good as an adiabatic process. Instantly it will become an adiabatic process. There will be cooling effect, and then the heat from outside will bring it to equilibrium. But in real study, if you take insulated container, the decrease in temperature is very large. There is a cooling effect as you expand by holding the piston in your hand, and I'm talking of the gas. Gas was there. I'm sorry. The gas was there at 20 atmosphere. Just you released slowly. Your work is to slowly reduce it. That means you imagine you are having 20 kg sand and you are removing grain by grain. Then even if it is slow and reversible, but it is adiabatic. No heat is coming out, just like isothermal to make U constant, temperature constant. But here the system is spending its own energy for expansion. And as a result, temperature will gradually fall. More the expansion, more is the fall in temperature. So in this case, all the three vary. Temperature drop is an expansion, and pressure drop, because volume will be more, pressure will be less, all vary. Unlike in isothermal, only temperature constant, and P and V vary in a reciprocal manner. But here there is no reciprocity. Temperature reduces, drops, pressure drops, volume increases. Of course, there is a PV relationship, but not is equal to constant. PV is not equal to constant, I'll tell you. Remember, have a copy with you. Have a copy always with you, because, and also another calculator will be solving problems. It's not that I will be lecturing and going away. I am telling, I am doing it public, because public might benefit, maybe 5, maybe 10. I am watching. The videos are being watched not by many hundreds and thousands, maybe 10, 15, 20, 30. That is enough for me. I don't want any publicity. I want to spend my time very peacefully and with all joy. That's what you guys are giving. Yeah. So, irreversibly and reversibly. It can also carry out irreversibly. In that case, now see the difference. Isotherm is here. The adiabat runs below the isotherm. You can draw it, sieve, below. This is adiabat. This is isotherm, reversible. This is adiabatic, reversible. Why it runs below? Because there is a temperature change. At a fixed volume, at the fixed pressure, volume is this for isotherm, but volume is less. For every fixed pressure, the volume of isotherm is more, volume of the adiabat will be less. Why? Because there is a temperature drop. According to Charles' law, if pressure remains constant, volume is directly proportional to temperature. So temperature decreases here. Temperature decreases means volume decreases. So supposing this, the volume, supposing this pressure, volume here, and this pressure, the volume is here. So the volume of isotherm is more than the volume of the adiabat. Or conversely, if you take a constant volume, then also the pressure of adiabat is lower than the pressure of isotherm. Because Amonton's law, less the temperature, less the pressure. Amonton's law. So it will run always below during expansion. But coming to compression, the adiabat will run above it. Why? Because temperature increases, there is a heating effect. The more and more you compress, the more heating it will happen. Temperature will be more, not due to any heat transfer. Q is not involved here. Work in the living present heart within God overhead. Work is involved here. So see, work is an equally important contributor to change in temperature. And isotherm, see, it has also its irreversible adiabatic, which is more than reversible adiabatic, area bound by the curve. So compression may, whether it is isothermal, this versus this, or it is adiabatic, this versus this. So compression may, irreversible work done is more, whether it is isothermal or adiabatic. And now there is a meaning for del H. Del H is always NCP delta T. Isothermal में delta T 0 होता है तो del H 0 होता है. You can explain in this way too. But adiabatic में del H has a value which is del U plus, because both P and V are changing. So here it is taken as P2 V2 minus P1 V1. But for exact differential अगर करोगे small change, so dH is equal to du plus d PV. So that means P dV, constant pressure into dV, plus V, constant volume into dP. That is the way how it is expressed as a function, exact differential. So that in a macro scale, it becomes P2 V2 minus P1 V1, but doesn't matter. We don't use this. We use this delta T to find del H. What is its meaning? Del H enthalpy change has a real meaning in isobaric process, but in other processes delta H is important because maybe the process is adiabatic in a 90% way or 80%, but it is, if it's somewhere there is open to the atmosphere, it is an open system, but still 90%, 80% insulation. In that case, grossly it is an adiabatic process, but the work output may be more than del U. So del H gives the total work output in particularly open systems. So del H is important even in adiabatic. Now coming to isobaric. Isobaric is the real hero where del H has a real meaning. The origin, the creation of enthalpy, the term by the scientists came from the constant pressure experiment. So here I have already told you that QP is equal to del U, that is QV plus P del V. So in place of del V, P del V, we can write nR delta T. Here mass remains constant. So what is changing with volume? Changing temperature. This is nothing but Charles' law. Here Charles' law is operating. Volume increases. So if there is an increase in volume is happening, graph is going in this way, volume is increasing, definitely temperature is increasing. इसके लिए ही वॉल्यूम इंक्रीज हो रहा है कि क्योंकि प्रेशर कांस्टेंट है, और कोई वजह नहीं है वॉल्यूम इंक्रीज होने का अगर प्रेशर कांस्टेंट है. अगर ये एडियाबैटिक नहीं है तो ये एडियाबैटिक, नॉन एडियाबैटिक प्रोसेस. Adiabatic is taken. So these are all. Isothermal is non-adiabatic. Isobaric is non-adiabatic. So there is a dithermic wall always. Then coming to isochoric process. Or isovolumic. Some people call isovolumic process. So that means V constant. Either you have a sealed container. I was explaining the bomb calorimeter, or any experiment you carry out on a dhakkan closed, or by chance del n is equal to 0, so there is no volume change. So whenever there is a volume constant, so that is called an isochoric process. In that case, since V is equal to 0, del V is equal to 0, then work done minus P del V is equal to 0. There is no expansion compression. I'm talking of expansion compression, work done 0. So applying the first law, that C will always say why chemistry starts from Q and why physics starts from del U. एक वजह क्या है? अरे वजह जो भी हो, आपका नतीजा वही निकलेगा भाई. del U is equal to, so this is Q plus W, this is 0. So simply del U is equal to Q. So in this case, Q isochore is a state function, path independent function, because it is related to U, another state function. Therefore, under isochoric condition, heat exchange doesn't depend on path, it is path independent. Just like work done in adiabatic is path independent, heat transferred in isochoric process is also path independent. Now, here also we have del H. Same N Cp delta T. Whenever you have del H, you have this del E, you must matlab QV. QV is del U. Already we knew from time immemorial. Del H is N Cp delta T. Or if we make, because temperature is changing, Charles law. If you say del U plus P is constant, P del V. So volume temperature, this P del V. Oh no, so volume is fixed. So if you say this is Hamilton's law. So general expression is P del V plus V del P. So if V is constant, del V is 0, so this term vanishes. So that gives you del U is equal to V constant volume into del P as del H. But we are not interested in this. We are interested in this, N Cp delta T. And in fact, isobaric and isochoric process, for the same temperature change, will have the same enthalpy change, N Cp delta T. You are carrying out a process by, keeping dhakkan closed, and if you are finding pressure is increasing, it is due to the increase in temperature. Hamilton's law. If you are making a movable piston that is pressure constant, then if it is increasing the volume, it is due to temperature increase. So this is all set and done. We are now going for an interesting process that is called cyclic process. Adiabatic, isobaric, cyclic process, which is very important. Cyclic process, in whatever manner we saw P versus B graph, started from here, you went here, maybe by two processes, maybe first by isothermal, then by adiabatic, isothermal expansion, then adiabatic expansion. It doesn't matter. You were coming here. This is initial point, this is final point. And again, you went back here. This is a cyclic process. You started from some point and you reached at that point. So cyclic process mein is exactly the same as isothermal. I mean, similar. Del U, because you are coming to the same thermodynamic state. So there is no change in internal energy. That doesn't mean that there is no work transferred or no heat. So if del U is equal to 0, according to first law, bank balance is equal to dollar plus INR. So this becomes 0. So again, Q is equal to minus W, or W is equal to minus Q. So that is definitely similar to isothermal process. Remember this. We shall be doing a lot of problems on cyclic containing minimum 4 steps or 3 steps minimum. It can go to 4 steps to come back to the original cyclic. Now coming, this is most important, neat. Often I have found questions from this free expansion. Expansion in vacuum. 6. It is also called free expansion. Now see, if you have a gas here and here there is vacuum, there is gas in a certain pressure, P1, V1, T1. So supposing you kept T constant or whatever, you make a small hole. The gas expands automatically, freely, from high pressure, some pressure to 0 pressure. This is pressure is equal to 0. So P del V is 0, not due to del V is equal to 0, but due to absolute pressure is equal to 0. So work done is 0. So the free expansion में क्या होता है? Del U is equal to Q plus W. So W is 0 on the ground of P0. So del U is equal to Q, just like Ishochoric process. But you have to carry out either isothermal. If it is isothermal, temperature is constant, then del U is equal to 0. Hence Q also is equal to 0, which implies Q is equal to 0. So if it is adiabatic, see, interesting. If it is adiabatic under insulation, then since Q is equal to 0, then delta U is equal to 0. So everything is 0. Everything is 0. Work is 0. Q is 0. Delta U is 0. This is 0. This is 0. This is 0. But something will happen. Later on we shall know that in irreversible process, I am telling you, in irreversible process, particularly fast process, there is an increase in entropy. Because second law will study that irreversible process, spontaneous process, will always involve an increase in entropy of the universe. It may not be in the system, may not be in the, maybe in the surrounding. Or there is a decrease in the entropy of the system and more increase in the surrounding. So sum total system plus surrounding will be greater than 0. So that in this case, there is an increase in entropy of system. System mein, because of expansion, the chaos will be more. We'll be talking about that. So we will be using the equation for finding out del S. But for if it is slow process, isothermal reversible, adiabatic reversible, then del S also is equal to 0. There is no change in entropy. Entropy is not produced in a reversible process. So we'll be knowing that. This is very interesting. And then now I'll ask you, in which case del H is equal to 0? Yes. See, I mean, all the isothermal, isobaric, adiabatic, isochoric, and cyclic, and free expansion, which we involves no enthalpy change. Del H is equal to 0. Tell me, just write down and just give me a minute. Yes, Shiv is writing. Shiv is isothermal खाली no. এইটি গোটে আমি ভুলি গলে যেতବେଳେ আমি when we are discussing about cyclic process, when del U is equal to 0, here also del H is equal to 0. Because there is no volume change, you just come back to pavilion. So original P into V is restored. Therefore, del H is equal to 0 in cyclic process. So, isochoric nahi, cyclic. And you will find another effect in isothermal and in cyclic and free expansion. I was just missing out. This free expansion, everything is 0. So let us list. That is why I wanted to refer. I should not do any mistake, miss out. As much less mistake done is better. So this is free expansion. Free expansion also del U is 0. So del H is also 0. Free expansion. And another which we will not study now is the Joule-Thomson effect. That is called throttle expansion. That is used in Linde's refrigerator. Throttled expansion. That is called Joule-Thomson effect. that we will study later, that also del H is equal to 0. And all these processes del H, these are called isoenthalpic process. These 4 processes. Otherwise, there is a meaning to del H. The actual discovery or the invention was done from isobaric, but it has got its importance in all processes. Excepting these 4. Can you give me a real life example of an adiabatic process that you have seen? Good. There are umpteen number of examples where in real life we are experiencing starting from formation of cloud to some of you have used a spray, if not a deo in your body, but room freshener also you must have used. You will find the moment you push, gases will come out into vapor. It comes from a high pressure to low pressure. Suddenly, even if the walls are dithermic, not exactly insulated, but suddenly it will be analogous to a near adiabatic process. So the expansion happens because of the investment of its own internal energy. So internal energy will decrease and there will be cooling. कुछ मिले तबे गोटे सेंट बोतल आनी कि मारुना तम देह को स्प्रे करो इट भी ठंडा लगिवो एवं बोतल भी ठंडा लगिवो से काहे ठंडा लागुछ why there is the decrease in temperature because this is an adiabatic process. Although for a common point of view ये तो glass is nearly insulation, plastic is really insulation, near insulation, 100% के keep even. Nobody can get 100% ideal thing. Yeah. Can you give an example of Ishochoric process? The real life process. It is the tire pressure is reduced in very cold countries in cold time, because during cold time when the temperature drops down very low, at that time, because the tire itself is so hard, tire will not contract. But inside the gas, there will be decrease in pressure, Hamilton's law. So when all of you will sit on the car, you have to again see how a pressure is increased. You have to go to the pressure pump. Because tire is so hard, it will not be compressed. But the gas inside will be having low pressure, Hamilton's law. The whole will be same. The kinetic energy is reduced. That's it. We shall be closing today with a very important and interesting aspect of adiabatic process. And first law is finished. We'll go to the second law tomorrow. And last day will be for thermochemistry. It's a relatively easier topic, all simple algebra. So I have kept one. I have not even scheduled the program. I will do that. See, pressure cooker is a bright example. I said that there are umpteen number of examples. Pressure cooker, you are cooking. Volume is fixed. But as you are raising the temperature, the pressure inside is increasing, so that the boiling point of water becomes more. So you are boiling your rice or any chicken at more than 100 degrees Celsius. So it quickly cooks. Yeah. Now see, interesting things will come. Let us try to put all them in graph. Starting point, expansion, ending point here. This is, you will tell me what is what. This is a straight line, vertical straight line. But it's not happening. Maybe due to my age or it's difficult. So, tell me this one, this one, this one. We have just now, this is, we are talking of expansion, going from V initial to V final. Means it is expansion, not compression. So, we are making an isobaric, this is an isobar. Pressure remaining constant. Volume is changing. And hidden other variable is temperature. It is hidden. It's not shown in the graph. We have to understand that this here Charles law is going on. Charles law is going on. Volume is increasing not from nothing. It is due to the change, increase in temperature. And this is isochoric, where definitely temperature is reducing. Temperature is not shown. Pressure is reducing means it is due to cooling, decrease in temperature. Isochor or isovolumic process, where this Amonton Baba will come. And this is obviously, we already have seen, this is isotherm, reversible, not irreversible. This is adiabat, irreversible. Sub reef. आर किसी रेप फेब नहीं, constant pressure तो. So, but yes, horizontal is isobaric. See, we saying green is horizontal, green is isothermal, red is adiabatic, and vertical is isochor. And in compression, you must know the difference. In compression, supposing starting point is here, it is V initial, and ending point is supposing here, V final, compression. So I am drawing, you will tell me which one is which. Of course, you can say, now you can say everything correctly. Doesn't matter, you know. Going to the same final volume. And it the volume change हवार नहीं केवल straight line हाथ. Okay, छाड़ो straight line. किए कोई परिवर्तन किए कोटा को प्रोसेस এইটা তো জনা পড়ি যাଉଛି গোটে দ্বিতীয় শ্রেণী মোর নাতুणी জিয়া को कहले से कहि दबो से कहबो जे तुमे कोन एमती स्ट्रेट लाइन को एमती कोन कलोनी मु कहबो मु हाथ थरुची बुढ़ा ही गेलेनी. So this is undoubtedly same volume means isochoric process. This same pressure means isobar, and between these two you know ऊपर रहिबो adiabat, because of there is a compression, there is a heat, sorry, temperature increase. I'm so sorry, temperature increase. So temperature बढ़ेगा तो volume बढ़ेगा, तो ऊपर रहेगा हमेशा adiabat, and this is isotherm. Accordingly, this is isotherm reversible, adiabat reversible. So I hope you are enjoying. Are you? Now let us. Are you? I hope you are enjoying. Are you? Is the you there? You there? Siddharth, are you there? Ritu, are you there? No communication, but streaming is going on. Are you there? Yes. Ritu? Ritu? My connection with Ritu might be having disconnection. Doesn't matter. I'll be putting them in YouTube and sharing the file. Now see, let us come to know what is irreversible work done. Adiabatic work done. Adiabatic work. Now here del U is equal to W. Yes. For any adiabatic process, del U is equal to W and del U is equal to NCV delta T. So that will give you, and that remember very carefully. Today the climaxing is coming. Climax. Del T, if known, then del U is W, which is equal to NCV dt for both reversible and irreversible. You know, reversible irreversible इसका अंतर बहुत ज्यादा है. रिवर्सिबल एक्सपेंशन में ज्यादा एरिया है, इरिवर्सिबल एक्सपेंशन में बहुत छोटा सा रेक्टेंगल है. तो यू नो इवन इफ इट इज आइसोथर्मल ना हो, एडियाबैटिक भी हो, फिर भी isothermal adiabatic reversible spends more work and irreversible adiabatic spends less work. But for only irreversible के लिए work done which is also equal to del U minus same principle P external into del V, V2, V final minus V initial. This will be applicable for this thing. Now I have a question, Shiv. Since work done in a reversible process is more, there is a more temperature drop. Supposing you have started your expansion from 273 or say 373 and you are doing slowly in a insulated container, you are expanding and finally you remained at some volume, 1 liter became 10 liter. You find your 373 has dropped to, we shall calculate now, the 373 has dropped to 260, supposing. And if start the experiment fresh from the same 1 liter 373 and suddenly expand to the same 10 liter. So will you get the final temperature 260 or more? Answer my question, more than 260 or less than 260? Answer my question. Don't tell me I didn't listen, repeat again. I am repeating again. You are expanding a gas adiabatically first, slowly, reversibly from 1 liter to 10 liter. The initial temperature was 373 and you noted the temperature was 260 K at the final 10 liter mark. You did the same process very rapidly under a constant pressure of, it will be given to you, P external will be given to you, but the same volume, 22 to 10 liter. Not with a regular variation of pressure, temperature, volume as we saw found in the graph. So the final temperature cooling होगा, वर्क एक्सपेंडिचर हुआ है का मतलब कूलिंग होगा, लेकिन फाइनल टेम्परेचर ज्यादा होगा रिवर्सिबल से या कम होगा? आप बताइए। आप शिव बोल रहा है, शिव बाबा बोल रहे हैं सेम रहेगा, और कोई है जो बताएगा कोई डिफरेंट आंसर, which could be correct, which could be wrong also. Here lies the role of a teacher. देखो, in reversible, the work done, the area bound by the curve is much more. Even the curve is lying below isothermal, but area bound by the curve is more. And in irreversible, it is a small rectangle. Yes. So if you do more work, exhaust more energy, tired more, so the decrease in temperature will be more. So the temperature drop will be more in reversible, 260 if it is 260. But in irreversible, you have spent only small amount of energy. So the temperature drop will be less. If the temperature drop is less, it will be landing at say 280 or 290 or 300, whatever. What depends on the external pressure under which you have expanded suddenly. So the temperature will be more for irreversible expansion, less for reversible expansion, because the work done by the system is more. The decrease in internal energy is more in reversible process than in irreversible process. You understood? Who has understood? Write down. C. Let us write down expansion is greater than W irreversible. So, final temperature of reversible expansion is less in less than irreversible expansion. So the final temperature drop will be more in reversible. You have spent so much of INR, so tomorrow bank balance will be reduced, temperature will be reduced. So reduce equal 260 achi. Now you are doing it suddenly and fast irreversibly, and the small rectangle is less, you are spending less INR. So the temperature drop, bank balance will be lower by small amount. So the final bank balance will be more compared to the reversible process. Got it? So, and compression is just the opposite. Compression is just the opposite. W irreversible will be more than W reversible. And there is a heating effect. Not heating, temperature rise. I will not say temperature rise. Compression will be done by the expense of it, by expense of our work. I am doing work. System is not doing anything. The surrounding is doing work. So it is pumping INR. So bank balance is increasing, temperature is increasing. So T will rise. But tell me whose temperature will be rising? In both the cases, temperature will rise in compression. But the final temperature of irreversible process will be more than reversible process. Just the opposite. In reversible expansion, the final temperature was less than the irreversible expansion. But in compression, the irreversible compression has more final temperature than the reversible compression, because irreversible big rectangle, than it acts against a high constant external pressure suddenly. So Let me tell you the reversible adiabatic gas laws. How will you know the final temperature? You cannot know the final temperature by using this formula. P del V. It is equal to nR delta T. No. Yes, this we will be using for both, but how to know the final temperature? The final temperature for irreversible can be known from here, which will be coming instead of V2 minus V1, V2 nRT by P. So you can convert, and you can P will be always same, but you can keep temperature as one variable. The initial temperature, you know, final temperature is only in V2 there will be a unknown T2, that will be unknown, and everything is known. T1 is known, so that T2 you can find. You will find it is 290. Here you have to find out using adiabatic gas laws. For reversible process they are applicable. But you will find it is 260. That's the difference. And once you find here using here what is the final temperature 290, you use in this equation to get del U and W. Or once again you use in this equation you get W. Or once again use in this equation to get W del U, which will be definitely less in expansion than del U in reversible. Less in irreversible expansion than in reversible expansion. Now, reversible adiabatic gas laws is not PV is equal to constant. Boyle's law is changed to PV gamma is equal to constant. Because everything is changing. Temperature, pressure, volume, all are changing. That is P1, V1, gamma is equal to P2, V2, gamma. Gamma I have told you, Poisson's ratio, Cp by Cb, which is always greater than 1. Cp is more than Cb by an amount R. And for the Charles law situation, Tv gamma minus 1 is equal to constant. That is T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. In this you have to use, don't write P remaining constant. Nothing remains constant here. And for Hamilton's type of equivalent between is this. Let me refer to this is second law. Second law, we will be finishing first law today. Yes. Yes. T1 by T2 to the power Cp, write down that. T1 by T2 to the power. This you have written, this you have written, but here the most useful equation is, remember this, you will tell me. Which power is Cp, which power is R, I used to forget. T1 by T2 to the power Cp is equal to P1 by P2 to the power R. Yes or no, or opposite? T1 by T2, P1 by P2 to the power R. Yes. So you will use these three equations whenever required, particularly these two, but this doesn't give you temperature, to get what is the final temperature. Then use that to get the work done or change in internal energy, whatever. Now the derivations are there in my notes. How these laws have been derived, they have been shown, you can understand. You guys are very good, you can understand. So let us solve a problem now. Let us solve a problem now together. In slide 106, we will be finishing, almost finished. We were not getting a cyclic process. Now, I can just snip this to our working file, so that let this class be a real learning program. 1 mole of an ideal gas initially present in an insulated piston. That means it is telling that it is an adiabatic process inside a isolated system. Is allowed to expand against a constant 1 atmosphere pressure. That means adiabatic and irreversible till the mechanical equilibrium is established. That is no more motion of the piston. CV is given. What is अगर नहीं दिया होता तो हम भी 3/2 5/2. No. Yes, that means it is indirectly telling it is a diatomic gas. 5/2 R का मतलब CV, it is a diatomic gas. Determine the final temperature of the gas and work done by the system. Calculate the temperature to attain if the expansion done reversibly. What will be the work done? Definitely work done will be more because expansion irreversible has greater area than the small rectangle. So let us find out the new temperature. Unless you find the new temperature, the final temperature, you can't find out del U. So for this it is easy. Let us solve this problem. Now to solve this problem, del U is equal to work done is equal to minus P external into V final minus V initial, del V. So that is equal to minus P external is given 1 atmosphere, minus 1 atmosphere into, in place of V final, it will be 1 mole. So N is 1. So RT by P, pressure is given, initial pressure 10 atmosphere is given by 10. The initial temperature is also given 400. Minus this initial final temperature you have to find out. I'm so sorry. RT2 or TF we have to find out. But the volume was ATP 1 atmosphere. I'm sorry, expansion 1. This is final expansion. So this is 1. Final temperature we are going to find. Final pressure, it is given 1 atmosphere. And number of moles is 1 minus V initial, nRT by P. So N is 1, R is R, and this T is given 400 by the final pressure is given 1 atmosphere. PB is equal to nRT can be used for initial state and final state. But the work done process, the equation that we used is the constant pressure outside here. That is important. We are finding the volume by using PB is equal to nRT equation. This is important, which makes the area a rectangular area. Otherwise, you would have made an integration area is larger. So, this is equal to N 1 CV is given 5/2 R delta T. So this is T2 TF minus 400. So you have to solve this equation. That in the left hand expression there is an unknown TF, and the right hand expression there is also an same unknown TF. So can you just calculate for me RTF minus 400 R? Sorry, this is 10. I'm so sorry. The initial pressure was 10 by 10. Minus 1 means minus is equal to 5/2 R into TF minus 400. See if I am doing wrong. I am looking to your sir mo data sarigala tenu mu baki tako kali YouTube ru dekhibi. Yes, I will be taking another 15 minutes to solve the problem and go. So Ritu be there. So ituru TF kete bharla eta 40 hela, R टा etu common चली गला, R TF minus 40 R टा कॉमन चलीगला माइनस अच्छी बाहर है 5/2 R TF minus 400 RR कटी गला भी. So it is 40 minus TF is equal to TF minus, oh sorry, 5 TF minus 2000 by 2. 2 will go here into 2. So it becomes 80 minus 2 TF is equal to 5 TF minus 2000. So if you go to this side, it becomes 3 TF is equal to 2000 minus 80, 2000 plus 80, because this will go to this side. So that is equal to 2080. So TF will be equal to 2080 by if our calculation is correct, then it will be definitely be less than 400. But how much less, we'll see. Tell me, if you have a calculator with you, you can also calculate. 2080 by 3. So it is, oh no, something is wrong. Something is going wrong. CV is delta T final minus T initial, 400K initial, and here RTF minus this is V2 RT by P, that is the final volume, minus initial RT by initial, initial pressure was 10 atmosphere, yes. And then we equalized minus RTF minus 400 R by 10. So R common, TF minus 40 is equal to 5/2. R gets cancelled. We are left with only temperature. So 2 LCM goes this side, 2 into, so I reversed, minus, because it was minus, I reversed 40 minus TF, so 2 comes here, and this becomes 5 TF minus 2000, and this becomes 80 minus 2F, 5 TF minus 2000. So, this is 7. I'm so sorry. Because this is not Zoom, you are not able to interact by words. So, this goes this side. So, this becomes 7. And this comes this side. This is 2080 by 7. That is 297. See, from 400K initial to, it has dropped to 297.14K in irreversible. That means more drop will happen in reversible. Are you watching, Ritu? Still? Or left? Anyone watching? This is the climax scene, but if you don't remain, it is already going to be 10, but not 10, 7 minutes more. I told you 2 hours, so another 6 minutes to go. Ritu, are you there? Anyone there watching directly? Anyway, you guys will watch later from YouTube. See, let us apply the adiabatic gas laws to find the final temperature in reversible. since you can apply, since volume data is given, no, pressure data is given, 10 atmosphere, 1 atmosphere. So instead of finding volume again, you can find the volume again. But instead of that, we shall be using T1 by T2 to the power Cp. Just now we have T1 by T2 to the power Cp is equal to P1 by P2 to the power R. So T1 is 400. T2 we are going to find out in reversible process. Cp is 7 by 2R. It is 5 by 2R is Cb. And this is P1. It is initially it was 10 atmosphere and now it is 1 atmosphere to the power R. So R get cancelled. So 400 by T2 to the power 7 by 2 is equal to 10. And then if you take the log, definitely you have to take the log and find T2. I have found out. So instead of wasting time here in the live program, I will tell you that T2 that I have found by using this one is 207.46. See, even it is lower than room temperature. It is 297, at least more than room temperature, more than 25 degrees Celsius. It will be less than 25 degrees Celsius. So much will be the work done more, so that the temperature drop will be more. The final temperature will be even less than the final temperature in irreversible process. Then you can find out del U is equal to W is equal to NR delta T in reversible. Is equal to 8.3. For the first time we are using R. Yes, that is one. Ritu is there. That is 297.14 we have done. And in the reversible process, not revision, reversible process, we are using the reversible adiabatic gas laws. Whatever data is given, accordingly we will be using. Otherwise, you would have volume data would have been given, then T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. But since temperature pressure data are given, so the final temperature in a reversible adiabatic process is much below than the reversible final temperature. It was 297, it is 207. Here you have to take log, power factor is there, you have to take log and find out. And then for the reversible process, work done, which will be definitely more, much more we will compare, is equal to NR delta T. This is final temperature is 207.46. The work done has to be negative. Expansion work is always negative, minus 400. So you tell me what will be the work done. Let me, before we close in 2 minutes, it is it is 1598 joules, approximately 1598 joules or 1.598 kilojoules. Is it correct? Just check. But del U irreversible is equal to same principle we will adopt. So instead of using P del V once again, let's use this. क्या फर्क पड़ता है, वही नतीजा निकलेगा. 1 into 8.3. This is 400. Oh, sorry. Minus. This has to be minus. I forgot. Expansion work has to come. Your chemistry class. And this will be again 297. The final temperature is 297.14. Oh, sorry. I am using that space which you cannot see. Is equal to 1 into 8.3 into 297.14 minus initial temperature is 400. This will come much smaller. Because 400 minus 297.14 into 8.3 it will be only 3000 something. Here, oh, I think here there is a mistake. There is a mistake. 400 minus 207.46 into 8.3. This is okay, but this one is, you have to find out 400 minus 297 into 8.3. Yes, it is only 853. Please, those who are watching later in the YouTube, please correct me if I am wrong in calculation somewhere. There is human. I don't claim I am doing everything correctly. So now see, work done or change in decrease, minus, has to be minus, a decrease. So is much less than about half of the reversible work done. So therefore the temperature is less. The temperature drop is more. So the final temperature is less, 207.46 in case of reversible expansion and 297.14 for irreversible expansion. In compression, it will be more. You will find the final temperature will be coming more in case of irreversible than because more work will be, because there is a big rectangle, more work will be done in irreversible compression, I'm sorry. So more temperature increase. So final temperature is more in case of irreversible compression, adiabatically done than reversible compression. With this, I think my agenda is complete. Then we will go for second law tomorrow. Just make sure that you enjoy the class. If later on in YouTube you are watching, please leave me a message so that I will be more encouraged. And if Ritu, because it was, you are the driving force for this lecture series, doesn't matter whether more number of people benefit or not. I'm sure C will be definitely watching the last part, and those who will be watching, they will get the benefit. They can do all these objective, whatever twisted, you can answer that. We will be doing. Tomorrow we shall begin with, because first law is over, we'll begin with 3-4 problems or objective questions from NEET last 3 years. I have selected, and also JEE involving only fast law, no entropy, no free energy, nothing. Bye bye. Bye bye. Ritu, bye bye. Anyone watching in the YouTube later on, also bye. Leave a message. How did you like it? And tomorrow at the same time in Indian Types 8, we shall continue second law with revision. Bye bye.